Welcome to today's lecture on environmental pollution and air pollution physics. In this lecture, we will study pollution from the perspective of physics. Usually, pollution is discussed in chemistry or biology, but in physics we ask different questions: how pollutants move, how they spread, how they interact with the atmosphere, and how they are eventually removed. Air pollution is one of the most important environmental problems because the atmosphere acts like a moving fluid medium. Once pollutants are emitted into the atmosphere, they do not remain fixed. Instead, they're transported by wind, mixed by turbulence, diluted by diffusion, and sometimes trapped by atmospheric conditions. In this lecture, our learning objectives are important because they define the foundation of this topic. First, we will understand environmental pollution as the disturbance of natural systems by harmful matter or energy. Second, we will explain air pollution as a physical process involving emission, transport, mixing, and removal. Third, we will identify the major pollutants and their sources. Fourth, we will understand how physical processes such as wind, diffusion, turbulence, gravity, and temperature affect pollutant behavior. Finally, this lecture will prepare us for later topics such as aerosols, water pollution, acoustic pollution, and radiation hazards. The course book shown here is Environmental Physics by Boker and Van Grondel, which we will use as a reference. Environmental pollution is studied in physics because pollutants move, spread, and interact through physical laws. For example, if smoke is released from a factory chimney, we can predict its motion using fluid dynamics. If pollutants spread from high concentration to low concentration, diffusion laws apply. If particles fall due to gravity, mechanics is involved. Air pollution is especially important because the atmosphere behaves as a moving fluid medium. It has pressure, density, temperature, and wind. All these factors affect pollutant motion. This lecture introduces the physical nature, sources, transport, and effects of pollutants. The image here shows an urban environment with visible haze and smog. This demonstrates how human activities can alter atmospheric quality. Environmental pollution is the addition of harmful substances or harmful forms of energy into natural systems like air, water, and land. Pollution disturbs the natural balance by changing concentration, energy flow, or normal system behavior. The pollutant may be matter such as gases, smoke, dust, and chemicals, or energy such as noise and radiation. In physics, pollution is often understood quantitatively. For example, if concentration exceeds a safe limit, it becomes harmful. If sound intensity exceeds a safe threshold, it becomes noise pollution. If radiation energy exceeds biological tolerance, it becomes hazardous. The figure here is very important. It shows both primary pollutants and secondary pollutants. Primary pollutants are emitted directly from sources like factories and vehicles. Secondary pollutants are formed later in the atmosphere through reactions. This slide summarizes the major forms of pollution. Air pollution occurs when harmful gases or particles accumulate in the atmosphere. Water pollution occurs when contaminants enter rivers, lakes, and oceans. Soil pollution occurs when harmful substances accumulate in land. Acoustic pollution occurs when sound intensity becomes harmful. Radiation pollution occurs when radioactive materials or harmful radiation expose the environment. The icons shown below represent these 5 forms visually: air, water, soil, sound, and radiation. This classification is important because each type involves different physical principles. Air and water involve fluid transport. Sound involves wave propagation. Radiation involves energy transfer. This slide is the heart of environmental physics. Pollutants move through physical media, such as air and water, so their motion must be explained through transport processes. Their spread depends on fluid flow, diffusion, turbulence, settling, and thermal structure. Their effects often involve measurable quantities such as concentration, pressure, temperature, sound intensity, and radiation dose. Physics helps us describe pollution, measure it, model it, predict it, and control it. The figure here explains the full chain: source, transport, measurement, and effects. Pollutants are first released, then transported in the environment, then measured using instruments, and finally their effects are observed on health and ecosystems. Air pollution is the presence of harmful gases, droplets, or particles in the atmosphere in amounts that disturb natural conditions. Since the atmosphere is a fluid medium, pollutants do not remain fixed. They move, mix, and evolve with air motion. Air pollution affects health, visibility, weather, and climate. The image shows industrial smoke entering the atmosphere. Notice how the smoke plume spreads upward and outward. This spreading depends on wind and turbulence. This slide introduces the major categories of pollutants. Gaseous pollutants, such as carbon monoxide, sulfur dioxide, nitrogen oxides, and volatile organic compounds, mix at the molecular level. Particulate matter consists of solid or liquid particles. Fine particles remain suspended longer because gravity is less effective. Larger particles settle faster. Secondary pollutants, such as ozone, form due to atmospheric reactions. The figure is very informative. It shows emissions from sources, molecular mixing of gases, long-distance transport, chemical interactions under sunlight, and deposition processes. It also compares fine and coarse particles. Primary pollutants are emitted directly from sources such as vehicles and industries. Secondary pollutants are formed in the atmosphere due to reactions influenced by sunlight, temperature, and mixing. The atmosphere is therefore not only a transport medium, but also an active reaction environment. The diagram shows examples. Vehicle exhaust and industrial emissions produce primary pollutants, which later transform into ozone or acid aerosols. The atmosphere behaves as a compressible fluid characterized by pressure, density, and temperature. Motion of air controls pollutant transport and dispersion. The relation between pressure, density, and temperature is P equals rho RT. Here P is pressure, rho is density, R is gas constant, and T is temperature. This means if temperature increases, density decreases, and warm air rises. The figure shows atmospheric layers and motions, such as rising warm air and circulation. This helps explain vertical pollutant transport. Pollutants are transported by wind, spread by diffusion, and mixed by turbulence. Their concentration changes continuously with time and space. The chimney plume image is excellent. It shows plume rise, lifting due to buoyancy, horizontal spreading by wind, and dilution due to mixing. Students should understand that pollution is a dynamic process, not static. Particles experience a downward force due to gravity. Larger particles settle faster, while smaller particles remain suspended longer. Settling velocity depends strongly on particle size. The relation shown here means if particle radius doubles, settling velocity increases 4 times. So larger particles fall much faster. This is why fine particles remain in the atmosphere longer and are more dangerous. This slide summarizes the lecture. Air pollution involves emission, transport, mixing, transformation, and removal. Pollutants are transported by wind, spread by diffusion and turbulence, and removed by settling or precipitation. Their behavior depends on advection, diffusion, turbulence, gravity, and temperature structure. The atmosphere determines whether pollutants spread or accumulate. Understanding these processes is essential for prediction and control. These questions are designed to strengthen your understanding. You should be able to explain the difference between primary and secondary pollutants. You should describe advection and diffusion physically. You should explain why turbulence enhances mixing. And you should explain the role of temperature inversion in pollution buildup. Please attempt these questions carefully. Thank you very much, students. In the next lecture, we will continue with particulate matter, aerosols, and atmosphere dispersion in more detail.